Welcome to Rough Science from the island of Carriacou off the coast of Grenada. 5 scientists have been taken from their nice, clean laboratories and brought here to this derelict lime factory, where they have to adapt their science know-how to solve a series of challenges. This is about science, not survival, so ingenuity and cooperation will be the keys to their success. The scientists have been exploring the whole island. They could do with a way of keeping in touch with each other. We really need some better way of communicating with each other when we're all spread out around the factory and around the island. So, physicists, do you think that some sort of transmitter would be good? I'm looking at you two, Jonathan and Kathy. Some sort of transmitter receiver, something that we can send signals to each other. And Ellen, do you think you could come up with a kite, some sort of like a big visual signal? But before anyone jumps on this and say, oh, that's easy, you could just put sticks up your T-shirt, it's got to be entirely botanical. And then time is going to be a critical thing. You know, when are these signals going to be sent? We need some sort of timekeeping device from the mics so we can coordinate things a little easier. So, and it needs to be portable, obviously, so we can wander around. But also I was thinking it would be really, really good fun if we could have like a Rough Science Big Ben at the factory that chimes on the hour. Don't you think? Big as you like, Mike. But it would just be fun, don't you think? It would be really, really fun to have that.
Make it easy for us.
Kathy and Jonathan need to make 2 things, something to transmit signals and a radio to receive them. Jonathan's a radio nut, so he's confident about a receiver, but to make a transmitter, we'll need a bright idea.
A spark, basically, electrical spark, produces radio waves. So we just basically want a thing that's going to spark.
So anything that sparks produces radio waves around it. Fantastic. So we just make lots and lots of little sparks.
And we try and make as much energy in that spark as possible.
OK, so we want a high voltage.
Yep.
OK.
So we've got a car battery for electricity. You never did... This is illegal in Britain to do
No.
this. Yeah, because the radio spectrum... No, it's because the radio spectrum has got all these radio stations and they all have to buy a licence for all the little place in the radio.
Yeah.
This thing, when you turn it on, produces radio waves everywhere. It's like really broad, so it will just wipe out.
So we'll wipe out the island's radio.
Yeah.
That's a bit drastic. But using their basic kit of tools, the first attempt at a transmitter starts to take shape. This is all about sending radio signals. Working out how to receive them, we'll have to wait. The big electric spark they need to blast out the radio waves will come from the energy stored in a wire coil, with lots and lots of turns. How many are we up to now?
283.
283. We've got to get to 1,000.
That one, I think.
Yeah, that's the loudest so far.
That's the chime, isn't it?
It sounds most like UK.
Yeah, but now we've got to work backwards, because we've done the easy bit, picking the chimes, we've got to build the clock.
Okay, that's it, yeah? This is the one.
To make a clock, they need to tell the time, and these strange bits and pieces are to make a sundial. But I've never seen anything like that in a garden.
This is the outer casing where the coconut fruits, and it's a nice, tight fiber. And we're going to make a pretty big kite. And so it needs to be strong, but I don't know if it's going to be too heavy, so I'm just going to make a prototype and then show it to Jonathan and Kathy.
So it's not the best kite.
How about some aerodynamics advice?
Guys!
I think it needs a bit bigger surface area. It needs to be a bit bigger to pick up the wind.
Okay. You want this thing to generate the lift to get over the weight of it so it stays up.
Okay.
Now, with an aeroplane, you've got the aeroplane flying through the air, and that creates the lift. With this thing, you've got it still, and you've got the wind passing over it. Okay.
So the wind goes like this.
Yeah, so the wind goes up like that over both sides.
Oh, both sides.
Both
Okay.
sides, yeah. And the way that the lift is generated is that the wind has to travel like further over this side than this side. So it has to go faster over here. Yeah.
Which produces a low pressure there.
Yeah.
And it's higher here, which tends to push it up.
Up.
Yeah.
Okay.
Back at base, this coil should transform a wimpy 12 volts from a car battery into hundreds of volts for a big transmitting spark.
The rule of radio engineers is always have one hand in one pocket and just use one hand.
Yeah.
Really?
Yeah, because if you're holding the chassis of things and you get electrocuted.
Okay, and the thing is, this huge voltage, right?
Yeah.
We're expecting the little spark to happen inside there.
Yeah, basically when the current goes through, it produces a magnet which attracts this and then turns it off.
Right.
And so initially, all that energy that's stored in there then produces a spark. It breaks down the air.
Yeah.
Because electricity can't usually go through air, can it?
No, it's just like a little tiny lightning bolt, okay?
Breaks down
So it's a
the
little
air.
baby lightning strike.
Yeah,
That's
not a big one.
incredible.
It's only going to be a little bit, but it shows you how much voltage there is.
Okay, am I allowed to swap between you so I can see it?
We'll try that.
All right, well, let's go.
Okay,
Let's go.
are you ready
let's
to go?
Mm-hmm.
Hand in pocket, like Jonathan says. Here we go.
Oh, wow.
You can see the spark.
Bright blue.
Yeah, it's lovely.
Hey, I want to see that.
It's all a bit scary. It's been going really, really well today. The transmitter seems to be practically there. It's buzzing away and sparks are coming out of it and everyone's cheering. Ellen really thinks her kite is going to fly, although from what I saw it didn't look too hopeful, but she's quietly confident. The mics, though, they've gone mad. Making a bong seems to be easy, but how will calabash fruit be made to bong exactly on the hour? You seem to have just gathered together a bucket, a tin can and thrown fruit around. I mean, what's going on?
What's going on? This is a prototype of our water clock. This just shows the basic principles, all right?
OK, go on then.
We've got a reservoir of water here, and we siphon water
Yeah.
into this reservoir. Now, in here, we've got a float attached to this piece of wood. So
Yeah.
as the water level in here rises,
Yeah.
this will rise. Now, what happens when this rises? You see this. This is the hour hand on the clock.
Okay.
This moves round like that.
Yeah.
So, at the start of an hour, it'll be in, say, that position.
Yeah.
And after an hour, a certain amount of water will have flown into there.
Yeah.
And it will have moved round to this position. So that is an hour on our clock.
All right, but how are you going to determine when an hour has passed?
That's where the sundial comes in, because you wanted a clock that chimes.
Well, it'd be
and we
nice.
can't make a sundial chime, although it's really easy to make and it's quite accurate.
Right.
But what we can do is use the sundial to mark the time from the sundial onto this face.
So you'll see on the sundial a very definitive hour passing.
Sure, yeah.
And you'll set your water off at the top of 1 hour
Yeah.
and mark it on
Yeah.
at the end of another hour.
That's
Yeah.
right.
That's
Yeah.
quite
And
clever.
because it's a constant flow,
actually.
we can then mark the whole face.
So we
I
just
take,
calibrate it.
I take back everything I said. That is quite clever. Late afternoon. Ellen's on an expedition. Bamboo is strong and light, just what our 2 doctors of physics ordered for the kite. How big is this kite going to be exactly?
One down.
Ellen's bamboo gets snaffled for the growing madness that is the bongs. Both mics seem to be getting obsessed.
Turn them over. Let's put 2 together. Yeah!
The sundial's not working yet. Apparently, its centre string needs to be lined up to exactly north-south, so that the shadow falls on a hoop that's lined up with the equator. And the string can't be lined up until it's dark. The Time Lords are waiting to see the North Star so they can point their sundial string to true north. With these clouds, they may be some time. Good night, boys. The sun's up, so is the solar clock set. By lining up the latitude, knowing where the North Star is, having this as your equator,
Yeah.
you know that when the sun is at midday, is at its highest point, it's going to hit this. Is that right?
Exactly, it'll be right at the bottom here. So I've divided this circle into 24. So 6 o'clock in the morning would be here,
Yeah.
and 6 o'clock in the evening there. A quarter of the whole circle, in the same
Okay.
way that it's a quarter of the whole day.
That's
and
really
night.
clever.
It is. I mean, I haven't got a watch, but I can tell you now, that mark there is 10 o'clock, that mark there's 11.
Yeah.
So I'd say it's between 5 and 10 past 10. It's that accurate.
Because of the shadow running
Because of
along
this
there.
shadow here.
So why the need for the water clock? Because of the chime.
Exactly. There's no way we can power a chime.
How's the coconut kite? Do you want me to help?
Sure. just break these open.
Mm-hmm.
Well, like this.
So this is just natural glue, is it?
Yeah. It may not be strong enough for this heavy coconut stuff, but what we're doing is just putting it along this line right here.
Mm-hmm. Okay. And what are these things?
They're acacia pods.
And how confident are you feeling
About the glue?
about the kite in general?
The kite in general would vary. The glue? Not at all.
Will you have to stitch it as well?
Yeah. This is bamboo, and I've made a cross.
Yeah.
This is 3 lengths to 2 lengths, which is a pretty standard ratio for kites.
How did this little one work?
It looked like a kite.
The spark transmitter should be sending out radio waves, but we can't tell without a radio receiver. A radio seems to involve yet more coils, a rusty razor blade, and a piece of coke, the stuff you normally burn.
The reason why we're using coke goes back to prisoner of war camps, where prisoners wanted to make a radio to listen to the outside world. They actually found by experiment that you could use all sorts of things, a razor blade. But one of the best ones they found was a piece of coke, which is just a bit of coal that's burnt in the fire without much oxygen. It doesn't burn away, it forms a little sort of crystal. And in fact, that's why the early radios were called crystal sets. And it used to have a curly bit of wire which went on it, which they called the cat's whisker. And you just point around on the crystal until you got the right contact. And the radio worked.
To test out whether the radio can pick up signals, it needs a wire aerial. A high one.
In the receiver, you don't have to have any kind of power. You just have your long aerial, and because that's being hit by the radio waves, it sets up a voltage across there, and that is enough to drive the tiny little circuit to enable you to hear the signal on the radio wave.
They're listening for any local stations, then they'll know if it's capable of picking up their own transmissions later on. The aerial's connected, the earpiece goes in, all hopes are pinned on the prisoner of war plan.
This is the one I'm much less confident about, but...
Anything at all? It's only crackle or anything?
when I make a connection, I can just hear a...
Should we try the other detector?
Yeah, I think so.
Nothing from the razor blade. It's coke or nothing.
Oh.
I can hear
I can hear a tiny bit of music.
Salvation. They've picked up the signal of a Christian station that broadcasts around the island.
We made a radio.
It works. Now they need to put radio and transmitter together to get real communication. Mid-afternoon and the quest for the perfect bong rolls on. With coconuts.
It's a little heavy, but I think it looks like a kite.
More complicated madness from the mics.
It started floating.
A float, tugging a string through a pulley, tugging a lever, releasing a coconut.
Can you see any movement?
No.
Well, the string's tighter, and it has moved.
Whoa, 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 whoa. Oh. The coconut's moving, it's about to go.
Yes! But it missed the gong. Oh, no. Oh.
Kathy and Jonathan prepare to transmit and receive. They need to spark out a signal strong enough to be heard blasting through the gospel station.
I can hear hymns, Jonathan.
OK, I'm wired up.
OK, I'm ready to test if you are.
Combinations of short and long taps send letters in Morse code.
I'm going to send you a K for Kathy, OK? 3 times.
OK.
Da-di-da.
Da-di-da. Just do it again. This is working, Jonathan. What? Hey! Come on,
and listen, it's amazing, you can.
It does work.
It does. There you go.
Yep. Yes. The buzzing noise. Yeah, definitely. Crackle. That was about 10 foot between the aerials.
I think it's further. I think it's at least 15.
15 foot!
While they're whooping, we're waiting for wind.
Now.
Okay, try now.
Well, I think that's all the trying we do today because it tore. Let's see.
So what do you think? What do you think you can do to make it better?
I think the first thing we do is sew this back on and then...
Yeah. And then learn how to control it.
The lightning bolt's transmitting, but only one day left, and there's no clock or kite. And tomorrow they're supposed to come together for coordinated communication. I think it's going to be a sleepless night.
This is the moment of truth. So, this afternoon at 3 o'clock, and that'll be up to you when 3 o'clock is, at 3 o'clock you will be splitting into two teams. Kathy, you happy to transmit?
Yep.
Ellen, you'll be with Kathy, and Mike, you'll be with Kathy. You'll have your wristwatch, which we haven't seen yet, but when your wristwatch says 3 o'clock, you give Ellen the sign to raise the kite.
Sure.
And Kathy, you start transmitting. Is that clear?
Check.
Yep. Jonathan, you're going to be on the receiving end.
Right.
Happy?
Yeah.
You're going to look for the kite, but you're also going to listen for the big bong
Okay.
as your signal that it's 3 o'clock and you should start receiving your message.
Okay.
I'll be with you. Mike, you'll be checking the bongs.
Right.
Okay? Are we happy? Kathy, what are you going to send? Okay. None of us have seen this message. At the end of it, we'll check whether Jonathan has what's written on this piece of paper.
About 3 hours to go, and the sundial timings have been marked on the complex Big Ben bong. The whole contraption should trigger a bong. An hour. Not very good bongs, and no sign of a watch yet.
Going home.
Last chance for the kite. It's supposed to be the visual signal for the radio team to start listening out for a transmitted message.
Okay.
More wind might help if it can stand the strain. Obviously, we've still got a lot to learn about the nature of aerodynamics.
I just think if we took hours and hours and just tried to figure it out, but the problem is we have hour,
Yeah.
so yeah, let's just go home.
Okay.
I gotta repair it.
Fine. Okay. Let's go do that now.
The mics have finally left their bongs alone to cobble together a watch.
Right, rough science time, lords. Have you got this little watch?
We have, yeah. It's a compact two-piece timepiece.
This is it.
This is it, yeah.
How's it going to work?
Well, it's similar to the big sundial,
Yeah.
except we haven't got a firm floor to put it on, so we need this pendulum to make sure that you're holding it absolutely upright,
Right.
because that can be inaccurate. And then we need this compass as well to make sure it's facing north.
I suppose it's sort of portable. Let
Yeah,
me
it's
try it.
portable.
How's it going to work?
There
Are
you go.
gonna
What
put
you
it
need
on
to
your
do,
wrist?
if you put it on your wrist,
Yeah.
the first thing is to make sure that this screw lines up with that screw.
Yeah.
And then the second thing is, using the compass, make it face north.
Okay.
You see that arrow?
Oh, yeah. Okay.
And you can tell from that that it's just gone 2 o'clock.
Okay.
So you can see that's 12 o'clock, 1 o'clock, and then this bit of charcoal's 2 o'clock.
Okay.
Might be just can't leave the contraption alone, and there's less than an hour to go.
It's such a hair trigger. It's so delicate. The slightest vibration on this metalwork just sets it off, and it's just like trying to prime, well, nitroglycerine or explosives.
This is the make or break test.
Let's go with that.
3 days of frankly messing about with fruit and the bongs have failed. The big finale is going to have to go ahead without Big Ben. It's nearly time. The mast goes up. The transmitter's got a super-duper coil for a bigger spark blast. And Kathy has a rough guide to Morse code.
About 3 minutes to.
Can she send her message at the appointed time? We're waiting with the radio for some sign of a signal. And Mike's standing to attention with his compact two-piece timepiece.
3 o'clock.
And it looks like Ellen's realised there's more than one way to go fly a kite. I can see the kite. I can see the kite.
Yes!
We should get transmission.
So that's why, yeah?
There's about 50 metres between our teams, far enough that we can't hear the noise of the transmitter. We have to pick it up the hard way. And it's not made any easier by the sermon coming through on the local station.
So we've got a T and an O by the looks of it. I don't know what that means.
Kathy,
Yep.
did you do long, short, long, long,
Yep.
short,
Yep.
Yep.
long, long, long?
No.
No.
I'll give him a really long break for the repeat. Okay, here we go.
And yes, put their needs above yours. So that when you say to someone, I love you, it means you put them first.
So it's Y something S, and I'm pretty sure it's an E.
Well, can you think of another word with which is Y something? Should we try it? Should we call them over and see what it is?
I think that's it.
Are you going?
Well, I got a dash dot dash dash da di da da, which is a Y, dit E, di 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 S. So it's YES.
Okay,
so
well
it's yes.
let's see because
My reputation stands on it.
I have the piece of purple paper. This is it, guys. Did we get communication? What does it say on the piece of paper? Yes! Brilliant. Well, that's all from Rough Science this week. Join us next time for more challenges. That was great. Absolutely. Now we just have to lie here.